Hello everybody and welcome to RedStone with Mackle. Mackle's my new friend, so I'm going to teach him how to do redstone stuff. Are you ready, Mackle?
I'm ready.
I'm ready. Alright, first off is redstone lengths. If you look at these redstone items that I have, I got redstone block and I got a redstone torch, right?
Mm-hmm.
They put out a redstone sigil, a certain amount of length. So this one, I believe it's 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, it's 15. They put out a signal of 15. So this torch right here occupies this block, and then after that it puts out a signal of 15 in every direction. Okay?
Mm-hmm.
So same with this redstone block, because it's the same thing. Puts out
Wait,
a
every
redstone
direction?
signal. Yep. 15, anything that's 15 length, so
How come it's not shooting this way?
because I didn't put a thing there. Let's look at this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, no, 11, 12. You know what I mean? So it'll end probably about right here.
What do you have in your hand?
Redstone.
Oh.
It's kind of like wiring, if you don't know that. But see how it ends right here?
Okay.
That's the 15th block that it's traveled in the power. And if you notice too, it goes dimmer, because this is where it's
Mm-hmm.
yeah, it counts down. Next up, if you look at it, is how the blocks work themselves. So the redstone block is here, right?
Yes.
And then after that, the 15 starts. So the top block up here, this redstone, right? This redstone wire, that counts as 1. So if you come down here and look at it, this is where the other ones end. And then this other one that I put like that on purpose ends 1 block back, because the top of it counts as 1 redstone signal length. Okay? Do you understand?
No.
No? What can I ask a question? I'll help you out.
What is the difference between this row and this row?
Is that it's where the blocks are placed. This is where the redstone block is, and then after that the 15 starts. So 1, 2, etc. But then over here, since I put it
But they
below
both
it,
end at the same spot.
why don't they?
No, they both do.
No, they don't. This one ends right here, and that one ends right there. The lengths are different by 1 because
it's glowing. Okay,
1
I
block
see,
down.
I see.
Yeah. Got it?
Uh-huh.
Okay, so that's length. Next up is how the redstone power spreads around, I guess you could call it, based on what you got. All the glass blocks on here is where the redstone power is located, based on what I got going on. So if you put a lamp here, say it doesn't light up,
Mm-hmm.
that means there's no power there. But if I put it right here, it's gonna light up from 2 sources, from the lever below and also this redstone poop up here. So anywhere those glass are, that's where it goes. The redstone poop that's on top of this block would transfer the power into this bottom cube, and then all the stuff around the bottom cube is powered because of that. I'm not sure about the very bottom. I think the very bottom might be powered because of the lever, but probably because of the redstone too. So anything around that block, because of that redstone on top, it transfers it down into the block. Okay?
It's a weird shape.
Kinda. So if we look at this right here, now this just gives an example of when you spread out redstone into a line. Since it's not a little poop that's rounded like this, all these spaces over here don't have, where I'm walking, don't have any redstone power going to them. See how the lamps don't light up?
Mm-hmm.
But because of how the rules of it going down into the block and around, this is a spot. And then I think down here is a spot too, yeah. If you look at it there. All of those are receiving power.
Okay.
And the power is coming from the lever on this side. So the lever is putting the power into the block, which then is powering the redstone here, and then this redstone over here is powering the next block and around it. So next
and
up,
so on and so forth.
yep, next up we got a lever here, which is giving power to the block. Everything down below the block is powered and around it, so that's why the lamp is on below. The redstone repeater only pushes the power into the next block. The blocks around the redstone repeater are not powered. The only reason why the bottom lamp is powered is because of this redstone that's right here. Oh, I lied, because of the lever and the redstone.
Okay.
So that means this block over here is receiving power, so all the glass around it is powered. And obviously this space right here is occupied by the repeater, but it would be technically considered powered if the repeater wasn't there, but then it wouldn't work. So you got it? Got it on that? Any questions? Okay. Next up, what do we got? What's this? Oh, this just gives an example of how the lever is putting power into the block next to it, right? And then everything, all this glass in a circle here is powered. So let's say we have this on. That means this over here, because that it powers this airspace over here from the lever. I don't know what this is for. It's probably nothing. Alright, next up we got torches. Torches do not power the block below them. So only this airspace around the torch is powered, and then the block above it, because it transfers the power up into the block, is powered around it. Torches that are stacked on top of each other turn each other off in a series like this. See how that one's off? So this is how you make wires going straight up and down, is they invert each other. Put that one up here so now that one's on. But when this torch below it gets turned on, the top one would turn off. So like, let's put a button down here, and I'll push it. Boop. That means the top one, they'll flip based on if there's a torch below it that's on. Okay?
Okay.
Okay. Now, the next one is a pressure plate. The pressure plate is putting power down into the block below it, and then the block is putting power in a circle, you know, a radius around that block. And since that happens, the redstone below is within that radius, so that will turn on, which then that redstone there will power all the blocks around the block below it. So all of the glass here is powered when I step on this pressure plate.
Okay.
Okay,
That makes sense.
good. Next up is pistons. A little tip with the redstone. Redstone is in ticks. That's how it's measured. And 1 tick is like 1/10 of a second. I think that's right. So 100 ticks in, no, 10 ticks in 1 second. So all these items on this platform here have a delay of 0.1, aka 1 tick. So like, repeaters are adjustable, so if I click it, this is 2 ticks, this is 3 ticks, and that's 4 ticks. That's how long it takes the redstone signal to go through it. So like, I'll do a little example. If you notice that when the redstone hits there, it doesn't light up right away. That's 0.4 tick. 4 ticks. 0.4 second, I guess you could call it. Okay?
Uh-huh.
Okay. I think pistons work at a half of a tick frequency. Is a little bit wonky. Those I don't really know the details on. Pistons can be powered... Pistons are weird, actually. Pistons are considered clear blocks. Michael, come here. You're getting lost. Pistons are considered clear blocks. So like... The way that this one works here is that the power from the redstone on top is going down through the block, which then touches this piston, the top one, right? But since the top piston is considered air, the bottom piston below it opens up. So like if I push this lever, both pistons open up. Because the piston above the bottom piston is considered a clear block, like a non-conductive block. No redstone can flow through it, kind of thing. But, oh, it looks, yeah, this, okay. Now, the hard part is explaining this one.
Yeah, why isn't this one working?
Since, I think, wait, try it now. No. Oh god. This one only opens up over here. This one, because what is happening with this system is that Minecraft has block updates. Are you stuck down there? Here, jump out of there. Minecraft has block updates. A block update is so that like it doesn't constantly have to poll the entire Minecraft world on what is going on. It only polls like when you press this redstone button, it tells the next redstone and the next redstone that this one's on, that one's on, and so on. And it goes through the whole series of the redstone. Just how the program works. But then, like, this one works like that because of the block update system. However, this bottom piston, technically, I do not think is supposed to be going open and close on this one here. But since, like, turn this one on again. Right here. Since you have this one on, when I put a block here, because of the block update, that's when the piston will open. Is because of the block update. So if you, wait, hold on. Turn it on. Again. Wait. Uh-oh. Hold on. Okay, turn it on. Now the piston's out, right? Now turn it off. Since I didn't block update this again, with the redstone, nothing's touching it to update it. From that series of, you know, the chain of events that you triggered when you turned on the redstone, this block stays open. Which is completely illogical because there's no power going to it. But since there's no update, it's going to stay open. Once a block gets set next to it, because that's a block update, and it updates the area around it, this piston will close. That's been like a Minecraft glitch for an eternity. Oh, look at that. Anyway, what's this one? Here's a pulse machine, for example. Here's something that you can build. The way that this works, remember how this is a one tick thing here? The redstone repeater? This will send out a 1 tick pulse through it because the piston is pushing the power off of it within that like 1 tick time. Boom. So if you look at these repeaters, only one is lit up at a time. That means there's only 1 tick pulse going through all of these series of repeaters. That's normally not good, but some devices you can build around this design, like the 1 tick design, which they are pretty... Here's a couple more inventions now, with all the knowledge that we know from over there that we can apply. This is a memory cell that I use in like everything that I make, right? In order to flop the memory cell, you'd use either the top... Here, I'll give you some... Actually, it'll make you fly. You can fly. The top has power on it and the bottom does not, right? Well, if I want to reverse that, I'll push this button down here and it'll turn the top off until I press the top button. So it's a on or off mechanism, basically. But that's probably the most important one that you need. Like in all of the designs, you'll see that everywhere, that signature S shape with 2 torches and a little redstone. Here's a pulse device. A lot of stuff also needs to have a pulse, because since on Minecraft you have power that's a stable on, you have to either turn it into like a zap of power, you could call it, to help out like certain devices the way that you build them. So here's an example. I'll put my torch down, but over here on this side, this one only pulsed for a second and then it turned back off. So like, let's get a note block here. I think this works. So if I put my torch back. Oh. See it? Yeah.
Switching, yeah.
Yeah. This one at the end, this is the output of this device, this torch, and it only blinks once. Because of the little pulsar that's here. Bunk. But here's the design of that. The next one next to it is just a smaller design. A lot of stuff can be shrunken down. Deathmire's the best at that. He makes the smallest things in the world. But it's the same thing. The reason why the end one pulses out is because this torch up here is maintaining the power above it, which then turns that torch off because they reverse each other. Like, let's do an example here. Put a torch up here, and then the power from the line is leading into this block. So that means this torch on this side of the block will turn off. Put some more power here. This torch on this block is on because there's no power leading into that block to turn this torch off. Oh. Did I kill ya?
Kinda.
So if I switch this around, that end torch will turn on every time I push this button. Or turn off, for that matter. Where'd you go? I think that's pretty much the basics of it that you should need to know. What does this do? Oh, here's a little secret too.
I'm still a little lost, but I think if I get my hands on it
Yeah.
and start experimenting.
Well, you turn on a clock. If you notice this one, this is a nice design where you can put power through blocks, like on a line that's already there. If you putting power into this block, right?
So why is there two torches?
I don't know. Oh, that's so you can
That is two torches,
you
right?
can set the delay. This is 0.4 tick, or 0.4 of a second. This is 1 tick, or 0.1 of a second.
It does that automatically if you put down two torches?
No, it's designed. This is a RedStone repeater. It's a block. I don't know if you can build here. Can you build here? No. But the reason why the power on this lever is going through this block and not powering anything around it is because the repeater on top. Stop that. The repeater on the top, and then that this one is putting power into this block, but every block around it is not going to conduct the power into any of these RedStone components, and the repeater does not get powered. The repeater only gets powered from the input side, which is over here. Oh. Here's an AND gate. These are pretty common too. Both torches have to be off to get this torch on this side to turn on with this little setup. There's a lot of stuff on like the wiki on how to make all these things, if it helps you out too. Like a lot of schematics. They're kind of hard to understand because they're not very user friendly. The OR gate. So it turns it like, because of RedStone, it turns it into like computer terms. Where you have like AND gate, OR gate, NOR gate, XOR gate, etc. You can build all of those in Minecraft because of the tools that they gave you. They decided to do that. But that's pretty much it for RedStone. Do you have any questions?
No.
Not really?
Not really.
Alright. Well, that's
Like I
it.
said, I'll have more questions once I start trying it.
Yeah.
So.